Okay, so big thing here, guys, with acceleration is this. For something to travel at a constant speed in a straight line, essentially in the perfect utopian physical world, that would require no force of any kind, okay, no energy of any kind, all right, for it to, or no work to be done for something to travel in a straight line at a constant speed, all right? But if you're going to change something's velocity, that is, you're going to make it accelerate, then you do have to put in energy, all right? This is why, if you've ever looked at like the fuel economy on vehicles, the city rating and the highway rating are always different. All right, because in the city, you're always accelerating, decelerating, accelerating, decelerating, and that takes your car has to exert more force, which means it has to use more energy to change your speed. Whereas when you're traveling along the highway, you put the cruise control on, and it doesn't need to work as hard to maintain a speed that is already achieved. All right, does everyone follow me on that? Okay, and the reason for that is something called inertia, which is also known as Newton's first law. Okay, now Newton was like the father of all modern physics. Okay, the big thing for Newton's first law is that not everything copied over. Okay, anyway, the big thing for Newton's first law here is that Newton, everyone puts him up on this pedestal. Everything he did was brilliant. A lot of the stuff he did was brilliant. Most of the stuff he did was write common sense stuff down in a scientific manner. Okay? Newton's first law goes like this. An object at rest will remain at rest. An object in motion will remain in motion unless acted on by an external unbalanced force. So Newton's first law is saying that that desk in front of Tara there will continue to do exactly what it's doing right now. Wow. And that's mind-blowing. That desk won't move unless someone goes and pushes it. And I mean, that's common sense. All right? Newton's second law is just as much common sense. His second law is that when you apply a force to something, its velocity will change. Okay, again, not rocket science. Used to do rocket science, but not really rocket science in and of itself. Okay, so inertia, right, is the tendency of an object, okay, in motion or an object at rest. And I'm not sure why all this stuff didn't copy over here, guys. We'll try this again. To stay doing what it's already doing. If you're going to change its inertia, that is, change what it's already doing, you have to exert a force. And when you do that, the object will accelerate. Okay, now accelerate can mean speed up, but it can also mean slow down. It can even mean change direction. All right? Acceleration is a change in velocity, and velocity is a vector quantity. So even if something's speed doesn't change, it could still be accelerating because its direction changes. All right? In order for you to turn a corner in a car, there has to be a force applied to the tires of your car that pushes you towards the center of the turn you're making. Okay? Everyone follow me there? You've probably experienced this where you were driving along and you go to make a turn, but it's really icy and you turn the wheels, but the car keeps going straight. Okay, anyone ever had that experience? Okay, well the reason for that is your inertia is to keep going in a straight line at a constant speed, and there isn't enough frictional force between your tires and the road to change your inertia. So your inertia is, I'm just going to keep going straight, right, until there's some frictional force applied that allows you to make that turn and change your velocity around the corner. Okay, so that's what we're going to be looking at a little bit today here. Okay. Right. Okay, now we talked about what acceleration was a little bit when we talked about velocity versus time graphs. Okay, and we said that if we have meters per second here and seconds here, and our line looks like this, that graph is telling us that the speed of the object is changing. Everybody with me there? All right, so if the speed of the object or the velocity of the object is changing, then it's accelerating. Okay, and we said that if we found 2 points on this line, that we could do a slope calculation where we do y2 minus y1 over x2 minus x1. Okay, but essentially what we'd be doing is going vf, the final velocity of the object, minus vi, the initial velocity of the object, over the change in time. Everybody follow me there? Okay, so that's where we get this formula from. That formula is on your formula sheet. Okay, the change in velocity over the change in time is the acceleration of the object. It's essentially just derived from the slope of a velocity versus time graph. Okay, Now, we talked about what the units for acceleration are the other day as well. Okay, we said that if I'm finding the slope of this line, I'm dividing meters per second by seconds. Everybody with me there? All right, if I'm going to be dividing these two things, essentially I'm saying this, and when I do division of fractions, I reciprocate and multiply or cross multiply, whatever you've been taught. Okay, so it ends up like this: meters per seconds times 1 over seconds, which gives us meters per second squared. Okay, which we could also say is meters per second, the rate of change of velocity. I'm changing my velocity by this many meters per second each second. All right, everybody follow me there? All right. So, calculating average acceleration, you're going to use this formula quite a bit in Science 10. Okay, it's the only acceleration formula that we now use in Science 10. When you get to Physics 20, I will pile 4 more on you. Okay, they're all relatively easy, and they're all still derived from this graph. Okay, just a lot more of them relate to the area underneath the line on this graph, which represents what? The displacement of the object. Okay, and so there's manipulations of that from there. Okay, so let's go through exactly how to manipulate this formula. So if I've got this formula here, guys, okay, A is acceleration, final velocity is VF, VI is initial velocity, and then T is time. If I want to get time by itself, how do I do it? Okay, remember again, rules of algebra are, if I want to move something, I have to do the opposite of what's being done right now. What am I doing to T right now in this formula? I'm dividing, so if I want to move it, I have to multiply. All right. So I'm going to move T over here. Now, T is over here with A, but I want T by itself. I'm multiplying T by A. So how do I move A? Divide both sides by A. All right, so A comes over here. Am I now solving for T? Okay, when in doubt, guys, if you've manipulated a formula and you want to find out whether you manipulated it right, check the units. All right, what's velocity measured in? Okay, meters per second, and what's acceleration measured in? Meters per second squared. So if I, instead of dividing by meters per second squared, I would reciprocate and multiply. Okay, so that would mean seconds squared over meters. The meters cancel, the seconds is gone, the squared is gone. What am I left with? Seconds, is that unit for time? It'll always work, guys. If you were ever in doubt that you didn't manipulate something correctly, just do the units. Okay, check the units and see if you did. And if it spits out the right units, you manipulated it right. Okay, that part most people don't have a problem with. That's the easiest manipulation of that formula. The manipulation people have trouble with is trying to solve, for one or the other of the V's. Okay. Before I can solve for either one of the V's, what do I have to move? T. Yeah, I've got to get T over on the other side because it's in the way right now. Okay, and I need it over here. Alright, now I've got T times A equals VF minus VI. Let's say I want to solve for VF. How do I get VI over here? Add it, okay? Now, this should make sense, okay? I'm going to re-explain how this is working. VF minus VI is the change in velocity. Everyone okay with that? Alright, so when I multiply T times A, that will give me the change in the velocity of the object. It won't give me the final or the initial, it'll just tell me how much it changes by. Alright, so if I take the change in velocity and add the initial velocity, should that give me the final velocity? Okay? Sometimes it helps to think logically about what you're doing too, right? Especially if you're an auditory learner. Okay? If you're an auditory learner, lots of times watching me manipulate this equation doesn't help very much. Okay? But if you can talk to yourself logically about what you're doing, this is the change in velocity, and the final would be the initial velocity plus however much it changes by. That kind of makes sense in your head when you say it to yourself. Okay? So, in order to get VF by itself, then I would bring VI over here. Okay, and I would add it to the change in velocity, or add it to T times A. Okay, everybody with me on that one? All right. Now I want to get VI. So what do I do now? Yeah, I can do that. VF minus T times A, okay, because essentially then I'm taking the final velocity, subtracting however much I changed it by, and that will give me the initial velocity. Now, mathematically speaking, here's why that works, okay? Essentially what I'm going to do, guys, is move VI back over here, all right, by adding it to both sides, just like I did before, okay? So now I've got VI plus T times A. Now, if I was doing this operation as it's written, would I multiply T by A before I added VI? Yes. So could I just subtract T times A over to here? Right? It's just a term, right? It's just I would do this before I added it anyway. So I can just subtract T times A over here and get VF minus T times A. All right. Now, a lot of you are probably going, that seems like a lot of work. I could have just left negative VI over there before. Yes, you could have. But what do you want to solve for? VI or negative VI? VI. Okay, so this will give you positive VI if you do it. So we move A over here. We move both parts of the T over, since for some reason it's coming apart. VF minus T times A gives us VI. Okay. So this, guys, is kind of going to be your first algebraic challenge of Science 10. All right, because I mean, you manipulated the mole equation. Oh, it was really tough. And V equals D over T, which was just as hard as the mole equation. All right, but now you've got several different kinds of operations. You've got multiplication and division. You've got addition and subtraction. All right, and it gets not so much in Science 10, but it does get tougher later on when you start throwing square roots in there and exponents and all kinds of other stuff. Right? Luckily, you don't have to deal with that too much in Science 10. Everyone follow me on how this manipulation works? Okay. I mean, your algebra skills are probably going to be a little bit rusty, but it'll come back. Okay, let's try this example here. So a sprinter starts from rest. What does it mean if a question tells you they start from rest? Right, they're at rest, they're not moving, so the initial velocity is 0. A question may also say comes to rest, which means their final velocity is 0. They have come to a stop. Okay, so sometimes you have to look for words that translate into numbers, right? Because it's very easy in physics to word a question in such a way to make you, who was perfectly capable of solving the problem, incapable of solving it because you couldn't figure out what it gave you. All right, and again, that's why we give you a mark for writing down your givens when you do a question like this. All right, so we've got a sprinter starting from rest, okay, and they reach a velocity of 16 meters per second. So my givens are that VI is 0 meters per second, VF is 16 meters per second, and this takes 4.5 seconds. Okay, what is his acceleration? So A is my unknown. I only have one formula that involves acceleration, VF minus VI over T. Do I have to manipulate this to solve for A? No, it's already set up. All I have to do is plug in my numbers. 16 minus 0 over 4.5. All right, so we get 3.56 what? Meters per second squared, right? Okay, and should I make that positive, negative, or leave it? Positive. Acceleration is a vector quantity. I need to indicate that this was increasing speed. All right. All right. How do I know to say positive and not forward from this question? They gave me positive in the question. All right. Always something to look for in a physics question, guys, is what did they give me for vectors? I need to make sure my answer follows suit. All right. If they gave me north, my answer wants to have north or south or whatever in it. Okay. If they gave me right and left, it has to be right or left. Okay. Questions on that first one? Okay. So, for the second one here, how long will it take a jet to accelerate from rest to 85 meters per second at a rate of 22 meters per second squared? What am I looking for? time. All right, so I'm given VI, 0 meters per second, given VF, 85 meters per second, okay, and I'm given the acceleration, positive 22 meters per second squared. Okay, so A equals VF minus VI over T. I need to get T by itself, so I'm simply going to swap it with A and be left with T equals VF minus VI over A. Right, then we just plug in our numbers. Okay, 85 minus 0, positive 85 minus 0, okay, over positive 22. Alright, we get 3.86, positive 3.86. What are my units? Seconds, right? I was looking for time, so my units are seconds. Okay, any problems there? Alright, so essentially, guys, I'm doing what I did back in the mole equation. I'm showing you an example of every way I can ask this question, essentially. Alright, for number 3, what will the final velocity of a car be if it starts at positive 15 meters per second and accelerates at positive 7.2 meters per second squared for 6.5 seconds? Okay, so again, we want to write down our givens. Okay, Alright, so that's what the question gives us. Right, we know we're going to have to manipulate this formula. Alright, but now I have to manipulate it for VF. Now we said, if I multiply A times T over here, that's the change in velocity. If I want to find the final velocity, I take the change and I add what? Whatever I started at, right? I mean, think about it this way. If I have $5 at the beginning of the day and I go to work, and I work for 8 hours, and at the end of the day, I now have, or at the end of the day, I've made $35. How much money do I have? $40. How'd you figure that out? You took what I started with, my initial money, and you added my change in money, and you got my final money. Well, it's the same with this, right? It's just think about it commonsensically that way. All right. So if I want to find VF, then I'm going to have the initial velocity plus the change in velocity gives me final velocity. Okay, then we just have to plug in our numbers. 15 plus 7.2 times 6.5. Okay, other way to think about this, when you go 7.2 times 6.5, you're taking, this is how much I change my velocity by every second. I'm multiplying it by how many seconds I'm going to change it for. All right, and then I'm going to add what I had at the beginning. That should give me what I have at the end. Okay, so we got 15 plus 7.2 times 6.5. Alright, so my final velocity then should be positive 61.8 meters per second. Okay, and putting in your positives and negatives, guys, is crucial, because you're going to run into questions like, you know, if I roll a ball up a ramp, okay, which way is it accelerating when I roll it up the ramp? Like, once it leaves my hand, it's actually accelerating negatively. It's accelerating down the ramp, right? So if it says accelerates down the ramp at, you know, 1 meter per second squared, but you push it up the ramp at 5 meters per second squared, your velocity and your acceleration are in different directions. All right, so you'd have to make one of them negative. Otherwise, what you're going to find at the end of the question is that it's somehow magically accelerated up the ramp, and that your final velocity is faster up the ramp even though it was accelerating down the ramp. Like, just stuff won't make sense. Okay. All right. Let's try number 4 here. How fast was a boat traveling initially if it accelerated to positive 30 meters per second at a rate of 2.6 meters per second squared for 8.9 seconds? So we know VF is 30 meters per second. Okay, we know the acceleration is 2.6 meters per second squared, and we know the time is 8.9 seconds. We're looking for VI. Alright, so acceleration equals VF minus VI over T. Alright, I'm going to move T over here, move VI over here, so I'm back to this, VI plus T times A equals VF, and then I'm going to subtract T times A over to this side, okay, to leave me with VI. Alright, so VI will then be 30 minus 2.6 times 8.9. Alright, so that gives us 6.86 meters, positive 6.86 meters per second. Okay, so are there really any big tricks to this? No, as long as you can, work the algebra, these are fairly straightforward, right? You have to read the questions carefully, though, in order to get the proper givens. Okay, one or two other things you're probably going to need to know to answer the questions on that worksheet, okay, are that the acceleration due to gravity is this, okay? And this is on your formula sheet, but we used little g to symbolize acceleration due to gravity, and that is 9.81 meters per second squared down. Okay. Alright, one last one here. Okay, I think it's the last one. Yeah. Alright. A ball is rolled up a hill. Okay, and this is the example I was just telling you about. Okay, is rolled up a hill at 4.5 meters per second. It accelerates down the hill at 2.1 meters per second squared. What's the velocity after 3.5 seconds? Okay, I'm going to give you guys a couple minutes to see if you can solve that one, and then I'll do it up here. Let's just have a quick look at it here, guys. Alright, so if we got ball rolled up the hill, our initial velocity is positive 4.5 meters per second. Generally, we make up positive and down negative. Okay, it accelerates down the hill at negative 2.1 meters per second squared, and then we're looking for after 3.5 seconds. Okay, so again, we start out with A equals VF minus VI over T, and we're looking for VF, so A times T plus VI will give us VF. Okay, and so that's going to be then negative 2.1 times 3.5 plus our initial velocity of 4.5. Okay, so alright, so our final velocity then is 2.85 meters per second. Okay, down the ramp. Okay, always give exactly the same vector that they give you in the question. They don't give you negative, they give you up a hill. Alright, so we should say down the hill. So it was 2.85 meters per second downhill. Well, no, because in the question they gave you down the hill. You assigned positive and negative to up the hill and down the hill, okay? But they gave you down the hill in the question. We give down the hill or up the hill in the answer. Okay? Making sense, guys? All right. Can you handle that worksheet now? All right, so let's get to work on that. Okay, if you have questions on it, let me know. Jess, I'll get you your copy here.